Hello, good morning. I'm discussing about rules of governing splitting of signals and some problem solvings related to NMR spectroscopy. Okay, first of all, rules governing splitting of signals. Only the neighboring of or vicinal protons cause the splitting of the signal, provided these vicinal protons are non-equivalent to the observing protons. Thus, we do not expect splitting in the flying compounds. Only the neighboring or vicinal protons cause the splitting of the signal, provided these vicinal protons are non-equivalent to the observing protons. Thus, we do not expect splitting in the flying compounds. For example, this is 1,2-dichloroethane equivalent protons. There is no proton on the carbon which is neighboring carbon. Adjacent carbon has equivalent protons. But in case of 1,2-dichloroethane, adjacent carbon has equivalent. But another example, okay, 1, 2, 3. 2,2-dimethyl chloro 1-chloro 2,2-dimethyl propane. There is no proton on the carbon, which is the neighboring carbons. See, uh, this carbon methyl groups have this neighboring carbon, but this neighboring carbon have no proton. And also this methylene carbon with chlorine have the neighboring carbon is this carbon, and that is the no carbon. Total area under the doublet would be twice the total area under the triplet due to the absorption by 2 protons, and triplet is due to absorption by 1 proton. The number of peaks obtained after splitting is 1 or more than the number of non-equivalent protons, that is n plus 1 on the adjacent carbon atoms, where n is number of neighboring non-equivalent protons. This is illustrated below for different types of protons. See, this is the adjacent carbon, this is the doublet, this is also doublet. This is the triplet due to 2 neighboring. This is the quartet, 3 neighboring. And this is doublet, 1 neighboring proton. These are the rules governing splitting of signals, and let us now discuss about some questions, questions or problem solvings related to NMR spectroscopy. Question first, how many signals would you expect from the flying? Also indicate the multiplicity of various signals. C2H5 ethanol, methoxymethane, and this compound, this complex compound, methoxyethane. In case of first example, there are three types of proton, methyl protons on the left hand side. Okay, what is the first? Okay, ethanol. In case of ethanol, there are three types of protons, these methyl protons on the left hand side on the ring, methyl hydrogens on the right hand side of the ring, and the ring protons, hence three signals will be obtained. All the peaks will be singlet because if we consider any observing hydrogen, there are non-equivalent protons in the molecules, so no splitting will take place. In case of exam second, structural formula is the, what's methanol? Okay. Structural formula of methanol. So there are three types of protons. See, this is one is the hydroxy protons, another methylene and methyl protons. Hence, three signals, it will be triplet for methyl protons and quartet for methylene protons and or singlet for hydroxy protons. There are only one types of protons, hence one signal, it will be singlet. Okay, for this compound. Only one types. There are three types of protons, hence three signals will be obtained. It will be singlet for methoxy protons and quartet methylene protons, triplet for methyl protons, methoxy protons. Okay, this is the methoxy protons, methyl and methylene protons. In case of third, there are only one types of protons. See, what is the third question? This is the methoxy methane. Second, first is this example. What's about this? There are three types of protons, methyl protons, left hand side of the ring, and methyl hydrogen on the right hand side of the ring, and the ring protons. Okay, the first methyl protons, ring protons, and this methyl protons. This is the one environment for this metal and another environment for this metal and ring proton. So three peaks in case of first example. Okay. In case of ethanol, also three peaks. In case of third example, methoxymethane, only one peaks, and IV, methoxyethane, three peaks. Am I right? Okay. Question number 2. An aromatic hydrocarbon C8 astane shows two singlet in its PMR at 2.3 and 7.05 with protons coupling in the ratio of 3:2, giving reasons assign structure to it. What's question? Aromatic hydrocarbon first, C8 astane, to singlet PMR signal 2.3 and 7.05 with the coupling in the ratio 3 is to give to, as reason assign structure to each. Okay. Three types of protons, three peaks. Structure first, two types of protons gives two peaks. From the question, only two types of peaks, so structure second is correct. Value of delta 2.3 is due to methyl protons and delta 7.05 due to ring protons. Such types of protons are in the ratio 6:4, that is 3:2, which is the guided by the questions. In this case, 3 peaks, in this case, 2 peaks. From the question, what tells us? Two singlet. Okay. 2.3 and 7.05. 2.3 and 2.3 methyl, 7.05 ring protons. Question note third. PMR spectrum of compound shows the following peaks. Delta 7.22, singlet 5S, and delta 3.59, singlet 2S, 2.77 quartet 2 hydrogen, delta 0.97 triplet 3 hydrogen. In the IR spectrum, that is strong absorption at 1705 per cm. Find out which of the following can justify the above spectral data. PMR spectrum compound shows the following peaks. Okay, structure have given structures A, B, C, D. From IR, so 17.05 carbonyl groups. So structure A and C is ruled out. Only B and D from the IR spectra. The probable structure is B and D due to IR strong absorption at 17.5 per cm. The PMR spectrum shows delta 3.59, singlet 2S, so only structure B is correct. To delta 2.77 quartet, 0.97 triplet, 7.22 singlet. Singlet, triplet, quartet. Okay. Singlet, triplet, quartet. What's about here? This is the triplet. 2, 5. This is the quintet. Okay. Question have given about quartet. Okay, quartet. So structure B is correct. A pure liquid sample was found to have a molecular formula of C6H12O by elemental analysis. It shows strong IR absorption at 1710 per cm. The NMR spectra shows two kinds of singlet protons and the ratio of 3:1 suggests the possible structure. Molecular formula C6H12O IR spectrum 1710 per cm indicates the presence of carbonyl group. One is NMR spectrum to singlet protons in the ratio 3:1. It means all protons are 3,3-dimethyl butane. All protons are separated by the carbonyl. Question number 5 gives structure consistent with the following set of NMR data. Molecular formula C9H12 singlet 3.22, 3 hydrogen singlet. Okay, what's about molecular formula C9H12 singlet tau value 3.223s singlet tau value 7.79s. In this question given tau. The formula C9H12 corresponds to the general formula of the aromatic hydrocarbon CnH2n-6. The compound seems to be substituted benzene. From the question, the compound gives the two signals. This shows that the presence of two types of protons. The above condition is satisfied by the 1,3,5-trimethylbenzene. This structure explains the existence of singlet tau value 3.22 due to 3 ring protons and singlet tau value 7.75 due to 9 methylene hydrogens. How many NMR signals would you expect from the following? Toluene 1,1-dichloroethane in allyl alcohol. Toluene, it contains two types of protons, the ring protons and the methyl protons, and two signals will be obtained. In case of 1,1-dichloroethane, there are two kinds of protons indicated by the A and B, and two signals will be obtained. There are 5 kinds of protons designated A, B, C, D, E, so 5 signals will be obtained. A compound having the molecular formula C10H14 gives the following PMR data. Singlet tau value 9.12, 9 hydrogen, singlet tau value 2.72, and delta value 7.28, 5 hydrogen. In this question, tau and delta value both are given. Assign a structure to the compound on the basis of above data. The formula corresponds to the aromatic compounds, general formula CnH2n-6, hence it appears to be a substituted benzene. There are 9 protons of one kind and 5 protons on another kind. It suggests that there is the mono substitution in the benzene ring. The two kinds of protons are not spin-spin coupled as we getting the singlets. The singlet tau value 2.72, delta 7.28 can be due to C6H5 phenyl group. Confirming monosubstitutions, the remaining part of the molecule, that is C4H9, can have the 9 equivalent protons only if it is in the form of a third butyl group. The singlet tau 9.12, delta 0.8 due to methyl protons. On the basis of the following data, assign the structure to the compound having the molecular formula C10H14, NMR, a singlet 2.7 tau value, 5 is doublet 7.5 tau value, 2 hydrogen, a multiflate 8.0 tau value 1 hydrogen, or doublet 9 tau value 6 hydrogen. Singlet at 2.7 tau correspond to hydrogen atoms of the benzene rings. or doublet 7.5 tau to hydrogen correspond to methyl, or multiplet 8. So that is a branching in the carbon side chain, or doublet 9 tau value 6 hydrogen correspond to hydrogens of terminal methyl groups. So 2.7, 7.5, 8, 9 tau value. You remember for ring tau value 2.7, delta value 7 point something, methyl 7.5, near about 3 delta value, CH tau value 8, delta value 2, methyl 9, 0 point something, 0 0.9, 0 0.1, near about delta value. You should remember the tau value and delta value of ring, methylene, methyl proton, and methane proton. A chloropropane gives a PMR spectrum as follows: triplet delta value 0.9, triplet more downfield as compared with above, but an intensity of 2 or 3 of the above, multiplied in the between the above triplets. Is the compounds 1 chloropropane or 2 chloropropane? Let us consider both of the possibilities, 1 chloropropane and 2 chloropropane. 2-chloropropane has only 2 types of protons and hence would give only 2 signals, whereas we are getting 3 signals. Hence the possibility of the compound being 2-chloropropane is ruled out, and it appears to be 1-chloropropane. Now 1-chloropropane contains 3 types of protons and hence 3 signals are expected. Triplet delta 0.9 is due to the methyl protons. Triplet is obtained because of methylene protons. Or triplet more downfield as compared to the methyl protons is because of the protons of chlorine. This is due to shielding effect of chlorine. The triplet, which is again due to methylene protons, will appear at delta 3:4. A signal due to methylene protons will be obtained at about delta 1.3. It will, however, be sextate multiplied due to 5 protons under 2 sides. The data given confirms to the structure of 1-chloropropane, suggests the structure on the basis of PMR data of the following compounds: C3H7 bromine, delta value 1.7, doublet 6 hydrogen, delta value 4.3, septate 1 hydrogen, C4H10O, delta value 1.28, singlet 9 hydrogen, delta value 1.35, singlet 1 hydrogen, C5H9, Cl3, delta value 1, doublet 6 hydrogen, delta value 1.5, multiplet 1 hydrogen, delta value 3.3, singlet 2 hydrogen. The structure is CS3, CSBr, CS3. There are 2 types of protons, hence 2 signals, 6 protons of one types and 1 proton of another types as given in the data conforms to this structure. The middle proton will give a septate because of 6 surrounding protons, and doublet will be obtained in respect of methyl protons due to middle protons. C4H10O is the molecular formula of butyl alcohol. A number of butyl alcohols are possible with this formula as given: CH3, CH2, CH2 OH. Structure second and third, fourth. The data given above conforms to structure fourth. have only two types of protons and gives rise to two signals. Structure first, second, and third would have given more than two signals, and all are ruled out, that is discarded. There are 9 protons of the one type, all methyl protons and 1 protons of one type. This is supported by the data singlet delta 1.28, singlet 9 hydrogen is because of methyl protons and delta 1.35 singlet 1 hydrogen is due to hydroxyl protons, okay? Out of the various structures possible, the structures which is conformity with the data, this is the methyl similar 1 pix, and this is the anode. So environment is the three types A, B, C. There are 3 types of protons and hence 3 signals are obtained. Protons designated A will give the doublet delta 1 and delta 1, okay, methyl, negative 0.9. Protons designated will give a delta doublet delta 1. Protons designated B will give a multiplet at delta 1.5. B 1.5, and protons designated will give C the singlet. All these products are satisfied by structure given above. A compound having a molecular formula C4H9Br gave the following PMR data. Doublet tau value 8.96, delta value 1.04, 6 hydrogen. Multiplet tau value 8.05, delta value 1.95, doublet tau value 6.67, delta value 3.32 hydrogen. What structure can the compound have? There are the 4 structures possible with this molecular formula. 1 bromobutane, 2 bromobutane, 1 bromo 2 methyl propane, 2 bromo 2 methyl propane. Structure first and second are 4 types of protons. Each structure IV has only 1 type protons. The data shows that the compounds contains 3 types of protons. Thus, structure first, second, and IV are ruled out. Structure third satisfies this condition and is this likely this structure. Structure third has 6 protons of one type of 1 protons of second type and 2 protons of third type which tallies with data. 6 methyl protons give a doublet due to tertiary protons. The tertiary protons gives a multiplet due to 6 methyl protons and protons in CH2Br. Finally, protons in CH2Br give a doublet due to tertiary protons. Thus, what is the structure which is consistent with data? Give a structure consistent with the following set of PMR data. Molecular formula of the compound is C9H11Br. Multiplet tau value 7.85 to hydrogen. Triplet tau value 7.25 to hydrogen. Triplet tau value 6.62 to hydrogen. Singlet tau value 2.78, 5 hydrogen. The data reveals that there are 4 types of protons. That is the benzene ring in the compound is shown by the singlet tau value 2.78, 5 hydrogen. The side chain in the benzene ring consists of C3R6Br and the 6 protons in the side chain form 3 pairs of different types of protons. The following structure satisfies the data completely. The signals given by the side chain are explained as under. The 2 protons on C3 give us signals. Triplet 7.25 it is split into three signals due to two protons on card C2. The two protons on C2 give us signals tau value 7.85 and it splits into 5 peaks due to 4 neighboring protons on C3 and C1 singlet downfield. Shift is due to on-shielding effect of bromine. The two protons on C3 gives a downfield signals tau value 6.62 due to the deshielding effect of bromine. The signals is split into a triplet due to neighboring protons on carbon 2. The structure is assigned above is consistent with given data. A compound having the molecular formula C9H11Br furnish the following set of PMR data. Singlet delta value 7.25 5 hydrogen, doublet 2.75 2 hydrogen, multiplet delta value 3.40 1 hydrogen, doublet 1.45 3 hydrogen. Assign a structure to this compound showing your reasoning. The data reveals that there are 4 types of protons, that is a benzene ring in the compounds as shown by delta 7.25 5 hydrogen. The side chain in the benzene ring is consisting of CS2, CSBr, CS3, and the 6 protons in the side chain form 3 different sets of protons. The following structure of for the compound satisfy the data completely. Okay, ring CS2, CSBr, and CS3. The signals given by the side chain are explained as under 3 protons on C1 give the signal 1.45. 3 hydrogen is split into doublet due to the presence of 1 proton on C2. 1 proton on C2 gives the signal 3.40 1 hydrogen. It splits into doublet due to the presence of 1 proton on C2. And 1 proton on C2 gives the signal 3.4. 1 hydrogen splits in multiplet due to presence of 5 protons on neighboring carbon. 2 protons on carbon 3 give the signal 2.75 2 hydrogen. It is split into doublet due to the presence of 1 proton on neighboring carbon 2. And organic compounds with the molecular formula C3H5Cl5 gave the following NMR data. A triplet 4.49 tau, 5.51 delta, 1 is. Or doublet 3.93 tau, 6.05 delta, 2 is. Assign a structural formula to the compound consistent with the above data. The molecular formula C3H5Cl5 suggests that it is a saturated molecules with no multiple bonds. Since we are getting 2 peaks, there are 2 kinds of protons, hence protons are attached to 2 carbon atoms. As a triplet and a doublet are obtained, it means there are protons on the neighboring carbon atoms. If the protons were present on the terminal carbon atoms, only singlet would be obtained. In the light of the above, the structure is CS3, CSCl, CeCl3, 2 types of protons. Compound with molecular formula C10H12O A strong absorption at 1705 per cm in its IR spectrum and NOR spectrum of the compound shows the following peaks. Delta value 7.22 singlet, delta 3.59 singlet, 2 hydrogen, delta value 2.77 quartet, 2 hydrogen, delta value 0.97 triplet, 3 hydrogen, giving reason assign a structure to the compound. IR absorption at 1705 per cm shows the presence of carbonyl group. The molecular formula suggests the presence of benzene ring. A peak at delta 7.22 singlet 5 hydrogen suggests that it is a monosubstituted aromatic compound. That is, there is only one chain in the ring, thereby remaining 5 equivalent protons in the ring. The possibility of an aldehyde is ruled out because in that case there will be 2 protons each of the 3 different types. This is not accordance with the data. The only possibility left is a ketone with the ketonic position 2, 3, or 4. A ketonic group sit at C3 satisfy the observation. The 3 protons C1 will give the peaks. It will be the triplet due to 2 protons at C2 0.97 triplet 3 hydrogen. The protons will give the quartet due to 3 protons at C post carbon delta value 2.77 quartet 2 hydrogen. 2 protons at carbon's port will give a singlet at carbon 2 delta value 3.59 singlet 2 hydrogen because there is no protons on the neighboring carbon atoms. Question number 16. A compound C3H6O contains a carbonyl group. How could you NMR establish whether this compound is an aldehyde or ketone? The aldehyde with the above formula will have the structure CH3, CH2, CSO. It will give 3 peaks corresponding to the 3 types of protons as follows: triplet 1 hydrogen, pentate 2 hydrogen, triplet 3 hydrogen. The ketone with the above formula will have the structure CH3CO CH3. In this case, all 6 protons are of one type and will give one peak, which will be singlet. This is how the identify of the compound can be established. Propose structural formula for the compounds with the following molecular formula, which if only on NMR signal: C5H12, C2H6O, C2H4Br2, C8H18. Since only one NMR signal is obtained, the compounds must possess only one kind of protons. The structural formula of the compounds accordingly: structure first, second, third, IV. How many NMR signals would you expect from flying toluene 1,1-dichloroethane allyl alcohol? In case of toluene, there are 2 types of protons in the ring protons and the methyl protons, hence 2 signals is obtained. 2 types of protons marks A and B, so that signal 2 signals. In case of dichloroethane, 4 types of protons mark A, B, C, D, hence 4 signals will be obtained. Discuss the NMR spectra of the following molecules: ethyl bromide 1,1-dibromoethane and 1,1-tribromoethane. Ethyl bromide CH3CH2Br. The NMR spectra of ethyl bromide is represented as follows: quartet delta value 3.4 and triplet 3 hydrogen 1.7 delta value. This is the tetramethylsilane, and is the NO spectrum of ethyl bromide. The following peaks can be identified in spectrum: triplet delta 1.73 hydrogen, quartet 3.42 hydrogen, the triplet at 1.73 hydrogen given by methyl protons, which are magnetically equivalent and are coupled with the two methylene protons to give the off field. The quartet at delta value 3.4 is from the two equivalent methylene protons, which are coupled with the three methylene protons to produce a downfield quartet as a result of desilting influence of bromine. The relative areas under the respective signals are in the ratio of the number of protons involved, that is 3:2. 1,1 dibromoethane CS3 CSBr2 NMR spectrum of 1,1 dibromoethane is represented as under quartet 1 hydrogen delta value 5.85, doublet for 3 hydrogen delta value 2.5. The following peaks can be identified in the spectrum: doublet delta value 2.5 3 hydrogen, quartet 5.85 2 hydrogen. Doublet at delta 2.5 3 hydrogen is due to three equivalent methyl protons, which are coupled with three methane protons as compared with the signals from the methyl protons CH3, CH2Br. The signal are somewhat downfield because of the presence of two bromine atoms on adjacent carbons. The downfield quartet at delta value 5.85 is from the methane proton, which is coupled with the three methyl protons. Its downfield position is due to attachment of two bromine atoms to the carbon carrying the protons. The areas under the peaks are in the ratio of 3:1, that is in the ratio of the number of methyl and methane protons. 1,1 tribromoethane CH2Br, CSBr2, the NMR spectrum of CH2Br, CSBr2, that is 1,2 tribromoethane is represented as under this is triplet and the doublet. The following peaks can be identified in the spectrum: doublet delta value 4.22 hydrogen, triplet delta value 5.7. The doublet at delta value 4.2 is due to the two equivalent protons of CH2Br group, which is split into a doublet by the neighboring protons of CSBr2 group. The downfield position of this doublet can be attributed to the desilting influence of bromine. The triplet at delta value 5.7 is produced by the protons of CSBr2 group. It is split into a triplet by the two protons of CH2Br groups. Relative to the doublet of CH2Br, the triplet of CSBr2 is more downfield since there are two bromines attached to the proton-bearing carbon in this case. The areas under two peaks are ratio 2:1. Discuss the NMR spectrum of the following compounds: isopropyl bromide, ethanol, acetaldehyde, benzene, toluene, paranitrobenzene. Isopropyl bromide is CS2, CS3, CSBr, CS3. Spectrum of isopropyl bromide is represented under doublet and multiplet. The following peaks can be identified in the spectrum: doublet 1.756 hydrogen, multiplet delta 4.31 hydrogen. It can be seen that the 6 protons on the methyl groups are all equivalent and different from the protons of CSBr group. These 6 protons give rise to an uphill signal at delta 1.75, which is split into a doublet due to coupling with the lone proton CSBR group. The proton of CSBR gives a downfill signal at delta 4.3, which is split into a multiplet by the 6 protons on the adjacent carbons. The 2 peaks are in the ratio 6:1. Ethanol, BC, 3 peaks. For hydroxyl, the singlet, and methyl 2:1 triplet, and methylene quartet. Following figure shows that the animal spectrum of ordinary ethanol triplet delta 1.2, 1.2, 3 hydrogen triplet 1.2, 3 hydrogen, okay, near about 1, and quartet 3.6, 2 hydrogen, 3.60, 2 hydrogen, quartet methane 3.63, 3.63, and cyclate 1 hydrogen 4.8 for hydroxyl 4.8. Ethanol contains 3 kinds of protons and consequently exhibit 3 signals as shown above. The upfill triplet of delta 1.2 is due to 3 equivalent methyl protons. Evidently, its splitting into a triplet is due to 2 neighboring protons on the methyl group. The quartet at 3.63 is from the 2 methylene protons. Its multiplicity of 4 quartet is due to coupling with the 3 methyl protons. Coupling with hydroxyl proton does not occur. Finally, the downfill at 4 delta value 4.8 is due to hydroxyl proton, which does not show the coupling with adjacent methylene protons. The relative areas under the peaks of methyl, methylene, and hydroxyl protons are ratio 3:2:1. Acetaldehyde NMR spectrum that I reproduce under, okay, CH3CS, 2 peaks. The spectrum of acetaldehyde contains flowing peaks doublet 2.2, 3 hydrogen. Okay, doublet. Quartet delta 9.8, 1 hydrogen. The doublet at 2.2 is due to the 3 equivalent protons of methyl group coupled with the single protons of aldehyde groups. The aldehydic protons observed far downfill at delta 9.8. The signals appears in the form of the quartet due to coupling by 3 protons of neighboring methyl groups. Peaks are in the ratio 3:1. In case of benzene, NMR spectrum of benzene is produced. Only 1 peaks. The NMR spectrum of benzene shows only sharp singlet 7.37 from the 6 equivalent protons. Such downfill signal can be explained in terms of pi electron system of benzene, which is considerably polarizable. Therefore, the application of magnetic field induces a flow of these electrons around the ring. This ring current in turn generates an induced magnetic field which reinforces the applied field. As a result, the benzene protons get shielded and the absorption moves downfield. Toluene NMR spectrum of toluene is reproduced as under singlet at 7.17, 5 hydrogen, that is ring, and singlet delta 2.34 for 3 hydrogen, that is the methylene. The following peaks are observed in the NMR spectrum of toluene: singlet 2.34 3 hydrogen, singlet 7.15 hydrogen. Toluene has 8 protons, 5 of which are aromatic and remaining 3 for methyl group. The signal from the 3 protons of methyl group, which is joined to the aromatic ring, appears as the singlet at delta 2.34. In practice, all the 5 aromatic protons are equivalent because they are hardly affected by methyl group. Hence, these protons do not couple with each other and give rise to only one signal in the form of the singlet at delta 7.175 hydrogen. It may be seen that relative areas under the two signals in the spectrum are ratio of 3:5. Paranitrotoluene. Okay, 3 types of peaks. NMR spectrum of the compounds is reproduced as above. The spectrum of paranitrotoluene has the following peaks: singlet delta 2.43 hydrogen, doublet delta 8.42 hydrogen, doublet delta 1.22 hydrogen. Of the 7 protons in paranitrotoluene, the 3 protons of methyl groups gives rise in the singlet at delta 2.43 hydrogen. The 4 aromatic protons are of 2 kinds. 2 protons which are ortho to methyl group are equivalent to each other, while the 2 protons ortho to nitro groups are equivalent to each other. The 2 protons ortho to methyl group gives rise to an absorption signal at delta 7.4, which appears in the form of a doublet due to coupling with the neighboring protons ortho nitro groups. Similarly, the 2 protons ortho to nitro groups produce a signal at delta 8.42 hydrogen in the form of doublet. The somewhat downfield position of the signal from these 2 protons can be attributed to the deshielding effect of nitro group. Discuss the NMR spectrum of benzaldehyde. The NMR spectrum of benzaldehyde is shown under. Benzaldehyde, BC, okay, 3 peaks. In the spectrum, there are 2 peaks. A singlet due to aldehyde proton is obtained delta 10 because of lack of coupling. A doublet at 7.5 obtained 5 hydrogens of the benzene ring. Splitting takes place due to aldehydic proton. Okay, it's all about some problem solving related to 1H NMR and rules for splitting. Rules for governing splitting of signals. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now. Bye bye. See you.